Hey grade 10s, welcome to my channel. I know I since last discussed some work on physics, paper 1 and paper 2 in the previous 2 years, if I'm not mistaken. Or was it last year? I don't know, I don't remember. But now let's just fortify your effort with mathematics, which is the main guy, by the way. Maths is the main subject into perhaps all sciences, if you will. Because one way or another in the sciences you're going to be involved in research, and this uses mathematical modeling to describe and to analyze data. So we might as well just try to get this right. Of course, the Northwest, guys, has been one of the provinces that supported my work, so much so that my channel grew through videos from the Northwest, because many students in the Northwest have really, been very helpful in ensuring that they're sharing, they're liking, they're commenting. In a way, the channel kind of, showed itself, but not really thrive in the social networks. And why would I forget the Mpumalanga guys? In fact, in the Northwest, I have a guy that is now going to be a fourth-year medical student next year. He's doing his third year now at the University of Pretoria. So we are producing, We are producing, guys. So, yeah, the guy is just doing great. And there are many others. Others are in PE doing, this business studies and chartered accounting or accountants. They're going to be the guys to count my money. We're going to make some money together once they finish. So we're going far, guys. This thing is going to start like this and think it's a popularity contest, only to find that is a very, very huge business investment on my part and even on theirs by yielding. Of course, I've got many others in Limpopo. Others are doing nursing. Others are doing, computer science in Durban. Others are doing actuarial sciences in UJ. Hey guys, it may not be very obvious, but the channel is doing great work. So if you stick alongside, please don't limit yourself to what I have here, but don't disregard it as well, because just combine everything together. You will see yourself thrive. So let's look at this question paper from the Northwest. Of course, guys from KZN, I don't see so much support from the EC. It's funny though. I'm in the EC, but if I post an EC paper, you don't really see so much good response. I don't understand why these EC people don't really support me. And yet I'm here with them. Goodness, these ones. They are really something else, are they not? Okay, we're going to take this question paper from the Northwest, grade 10s, paper 1. Of course, this says pre-test. Maybe it's a mock test or something, but either way, it will just highlight some areas that need to be paid attention to. So it's a 1-hour paper, but I may double that to try and give you guys a clear perspective on how to do things. It's not about solutions. It's about understanding how to generate those solutions so that you can have a good standing in the subject. Of course, instructions, guys, we need to read with understanding. Please commit these to memory. When it comes about rounding off and how to do calculations, many people miss this part. Etc. means if a theorem is used, we need to state it. Okay? If some law perhaps, or some logic, whatever that may be, we need to showcase it or at least state it if it is something stateable. So do not ignore that. Of course, diagrams are not necessarily drawn to scale, but we do not want to read too much from that. But proportionately speaking, it should still send the correct message. Any diagram not to that effect is a bad diagram. It just says the entire process of, preparing the question paper, the coordination process, the quality assurance are all terrible. And this is quite a common finding in our country, especially on the provincial papers. So this needs to be stopped, if not limited. And the only one way to do this is to ensure everyone is checked irrespective of who they are when they submit questions or when the question paper is put together. Okay, it shouldn't be, Makamba knows maths, so that's right. No, mistakes do occur even to the best of us. Of course, I'm nothing, not a teacher, I'm not a mathematician. I'm simply a fanatic who wants to share my experiences and my understanding, my ability to look at things and to show others so that we can all see in the better light, not necessarily to see it my way. Okay, now let's get to this question 1. We are asked to determine the following without the use of a calculator, meaning if we show up with a decimal in a question like that, we are dead. Okay, so we are asked between which two consecutive meaning one after the other, right? Or we can say one before the other, because they should be of increasing order, right? Left to right. Okay, between which two consecutive integers lies minus the square root of 69. Now if we evaluate this number under the square root or the surd or the radical, it's not a perfect square. Okay, so if it is not a perfect square, so what is the procedure? We are going to look for the perfect square before this number. 69, the immediate perfect square before 69 is 64. And the other one immediately after, so we look at those two ends, it's going to be 81. Okay, so this simply says the square root of 69 should be between the square root of 64 and the square root of 81. That would be 8 and 9. So we look at the index of the radical, or the order if one would look at it, but it's often called an index. So if there's nothing written there, it means it's a square root. It means the number is a 2. We normally don't write a 2 there. So it is a 2. So this means we're taking the square root of 69. But since this is not a perfect square, so we want to approximate where do we expect to find it. So the best way is to find the immediate square number before the number we see and the immediate square number after the number we see. But now there's a bit of a tricky state here in that this whole square root is to be negative. So we need to adjust our integers as well to be negative, because this is going to yield a negative real number. But now we want to also make sure our integers are also negative. All right. So how do we go about this business? So we will say, okay, fine. By the way, let me highlight something. All right, guys. So whenever we solve a mathematical problem, we usually circulate between these 3 steps. These are the main steps with multiple actions in between. Usually step 1 constitutes 80%, over 80% of the actions that we take in solving problems. Step 2 and 3 are more like, the keys to a lock. Once unlocked, we go back to the mainstream, right? So we need to know the order of operations, BODMAS, meaning brackets, ordinals or exponents, division, multiplication, addition, and subtraction in that order. Although we know division and multiplication can be, interchanged somewhat in terms of priority, as well as addition and subtraction, depending on the structure of the algebraic expression or arithmetic expression we are looking at, okay? But remember as well that when we do BODMAS, we tend to do it in reverse, meaning doing the so-called reverse operations, all right? Now we can do this applied. Perhaps when we do trigonometry, we can talk of brackets off as representing reduction formulae or cofunctions. The AS part could easily be just special angles, things like that. And then we talk of factorizations. This is when we do the most basic, highest common factor, or the little bit complex one, the difference of two squares, or literally polynomials, which force us down the path of long division or grouping. Sometimes by inspection we can do this, especially with a quadratic trinomial, which is the common one. Then step 3, we can talk of laws. Could be an identity, could be a theorem, could be a formula, could be logic, etc. All right. Now this is usually where a lot of other topic-specific areas are to be considered in different sections of the paper. All right. So we're going to look at this in terms of these 3 steps. I'll try to highlight this so that you can understand exactly what we are doing. All right. So now let's get to business. 1.1. We need to deal with this. Okay, so we can safely say, well, we understand that minus the square root of 69 should be less than minus the square root. Now remember, with integers, we know that the smaller number, when it is negative, it's going to be the bigger number. So we're going to put 64 here, greater than minus the square root of 81, right? Remember the order in which we list integers on a number line, okay? So this means that this square root of 69 is going to be less than minus 8, greater than minus 9, and that's it. So very easy, not too complex. In fact, in the NVTs, there's a question I've done on the channel. You will find it, but it looks like it was one of the tutorials by one of the popular maths tutors on YouTube, because it's similar to how he highlights his work, I noticed. So yeah, it had something to do with square roots, but now this time of bigger numbers. So one had to understand how to deal with that issue using this kind of logic, because this is when we approximate where this should be. All right, great. So we need to understand this. We need to understand this, guys. And I would say, please note this thing, because some higher grade questions can be brought from this. And please make sure you score those marks. So we get our 2 marks. Nice and easy. So basically we just followed a law, if I would call it, or even logic. Perhaps it's best to say this is logic. So literally on the first part, we just used step 2 to identify the perfect squares, because this is a square root, so we needed perfect squares immediately before and immediately after. But because this is a negative number, then we need to switch the positions, because we always list our integers from the smaller to the bigger. Okay, and of course we just take the square roots of those perfect squares, and this will fall in between. We can check this with the calculator and say minus the square root of 69. Then we press our SD button. It says minus 8,3, and indeed minus 8,3 is in between minus 9 and minus 8. So this means we are set. Okay, so of course when we take the square roots, what are we doing? Reverse operations of ordinals or something. So this is more like step 1 going into our answer. Okay, so we used only 2 steps there. Great, so let's go to the next question. 1.2. We are to solve, show that 0,9 recurring is equal to 1. So basically 0,9 recurring is something like this. It's basically 0,99999, and the pattern continues endlessly. So we are saying, well, a recurring fraction or decimal, should we say recurring decimal, actually is a proper fraction, right? Not an improper fraction. Am I wrong? Yeah, it depends, of course. If this is 1 comma something, it's going to be an improper fraction. But if it is 0 comma something, it's a proper fraction, right? Right. Now, we also know something about decimals, right? We know that technically decimals, let's take, for example, 0 comma 56. We know that a decimal number has two components to it. It has an integer component and it has the fraction component. Now the integer component is usually the one before the decimal. So this is 0. 0 is an integer. Spare that, it means nothing at this point, but it's an integer. Then we added 0 comma 56 to it. Right? Right. So what are we doing here? What are we doing here? We are told that, look, every digit after the decimal represents a fraction with that number being the numerator and the denominator being the increasing orders or degrees of powers of 10. Okay, what do I mean? This is 0 plus, okay, we can say 5 over, because it's on the 10th position, it's going to be over 10. So that's a power of base 10, the first degree, right? 10 to the 1. Then we add, the next number is going to be 6 over. Now, since this is on the 100th position, not hundredths, 100th. All right, so this is going to be over 100 and so forth. Now, of course, this is 0 over 1. We follow the same idea. We look, is there a common denominator? Yes, it's 100. So we divide by 100 here. Then we say 100 divided by the first denominator, it's 100, times 0 is 0. Then we say plus 100 divided by 10, it's 10. 10 times 50 is 50. 100 divided by 100 is 1. 1 times 6 is 6. Then we simply add the numerators. 50 plus 6 is 56 divided by 100. And usually we tend to jump for the jugular when converting decimals into fractions. We know that if there's two decimals after the two digits after the decimal, then this means this is over 100. If there's nothing here, it's going to be just that number. So we normally just jump for the jugular, but this is the process that we know that any decimal has the integer part as well as the fraction part. The fraction will depend, of course, on what we have. Of course, if the integer is any number greater than 0, it means our fraction is going to be an improper fraction. If our integer here before the decimal is 0, it means our fraction is going to be a proper fraction. Okay, so this is the idea we need to carry with us, that when we're doing this is what we're doing. And in fact, this becomes very important in grade 12 when doing sum to infinity, because we change these recurring fractions using sequences and series, specifically a convergent geometric series. But then that is going to be learned in grade 12. I was just adding some notes on you just to see what is cooking with decimals. And essentially, I would highlight a student must know how to convert between decimals and fractions to decimals. Now, folks, what are we doing? We are supposed to show that this is equal to 1. Now, there's a grade 10, perhaps acceptable technique, which we can do. So we just go and say, let x be equal to 0,999. Maybe let's keep them manageable. So we say that is the one. So we're going to say this is equation 1. Okay, number 1. Then we say multiplied by 10. Now, in maths, guys, we know logically, we can multiply by anything we want. But now the question is, what informs us multiplying by 10 instead of 2 or 3? Why 10? We look at our recurring digit. the recurring digit is 9. It's just a single digit that recurs. So this is in the 10th after the decimal. So we multiply this by 10. Now the rule is when we multiply by anything in an equation, if we're multiplying on the left hand side, we must also do on the right hand side. So this becomes 10x is equal to, when we multiply here, the 9 jumps into the other side, and then we end up with this. But of course, these ones that we're hiding here, this one can show up. We just want to show it because remember, these are infinitely as many as we see them, okay? So this becomes equation 2. Great. Now can you see, this is the concept of simultaneous equations, essentially. So what do? We will say then, we're going to use the elimination method instead. Equation 2 minus equation 1. So what do we see? 10 minus x is going to be 9x equals 9 minus 0 is 9. And literally 0 comma this is going to take care of 0 comma that, right? Yes, infinity is infinity, baba. So the concept of infinity needs to be clear in our heads because some questions keep coming in different formats in algebra, even in trigonometry. Like lately in the grade 12 questions, there was a question on infinity there. Of course, it uses the telescoping effect of certain terms depending on the arrangement of these on sort of like a linear scale, if I would put it, or should we say on an expression. So we can clearly see here that when we divide by 9, we see that x is indeed 1. But the question was not on x, so we can say therefore 0, 9 recurring is indeed 1. So we must always answer the question. Great, so you will appreciate this when it happens with sequences and series in grade 12. Remember, it's coming back. If you want to just see this out of curiosity, but please don't apply what you will see there, because it's only applicable for grade 12. So you only do the convergent geometric series in grade 12. So wait for it, okay? Wait for it. If you use that technique, then it will become suspicious if your teachers didn't help you out at all, because how can they teach you something that is already 2 classes ahead of you? It's dangerous, ne? So this is the one we can accept, and any other one that perhaps is within your reach. But this is the essence of what we're doing here. So if you are interested in checking this out, go to my channel and check Eastern Cape Paper 1, September 2022, or the trial exams. You will see there. It's there. It's there. You will appreciate the technique. But at this point, simultaneous equations, essentially within reach for you guys. This is the way. Please note this thing as well, because this is a common question and marks can be lost if not understood. Okay? Marks can be lost if not understood. Now, how do we score marks? Well, solving for x, I guess. This portion right here and that portion, I suppose. But I think more importantly, that gymnastic, we can say both of those two, 1 mark, and then the 2 gymnastics are much more interesting. As you can appreciate, guys, in terms of the 3-step approach, so we kind of let something, this is a logical thing to do. So this is step 3. To multiply by whatever we think about, again, it's some kind of a law, right? And also to multiply on both ends. It's logical and law, so basically all of this is step 3. We kind of maintained it. And then when we add and subtract things, this is more like AS in BODMAS, so like terms and stuff. So that is step 1, okay? And then we come in here, division and multiplication, step 1. And it leads us to our solution. So essentially, that's how the 3-step approach helped us here. Of course, you're not always going to use all 3, but whatever you do, you will almost see that step 1 is almost there, because this is the final common pathway. Algebra or arithmetic is like the carpet yakwa maths. The rest is decorations. All right, okay, all right. So we've got our 2 marks. Please, guys, note the techniques of solving the first 2 questions in question 1. Please do not overlook this. Now, I wanted to highlight something. If, for example, we've got 0,919, okay, maybe let's do this. 9 recurring and 1 recurring. So we can see there's 2 digits after the decimal that are recurring. So when we do this multiplication, we're going to multiply by 100. If we've got 0,1923 recurring, now there's 3 digits that are recurring after the decimal. It means when we do this step, we're going to multiply by 1,000. Please note these kind of things. This is very important, okay? Good. I'm sure this is clear. This is usually not too complicated. Students usually can handle this easily. Question 2. Question 2.1. We are asked to factorize. Now, this is a skill, guys, that needs to never escape the mind of a mathematics student. It is key to many issues. If this is not understood and it is not performed in a second nature kind of style, it becomes a very horrible experience. So we look at that expression. We've got 3x squared plus 9x minus 2xy minus 6y. Right, we can see this is a polynomial. There's 4 terms in here. Now remember, anything more than 4 terms, we will hardly be able to factorize using the inspection and perhaps the bracket method. Usually it's a trinomial that we can do that. But anything more than, anything more than 3 terms is a bit technical, especially when the variables are not the same. So what does it mean? We are here at the polynomials, and in fact grouping is going to work in our favor. So can you see step 2 is in the house. We need to do grouping and factorize. So we will do this in the next step. 3x squared plus 9x, these look alike. Right, we group them. This time we are forced to pull a negative. Then we get 2xy plus 6y. That's how we can group that effectively. So remember, the next term usually forces our hand if the sign is negative. But if this was positive, we could easily just write it there and keep everything as it is. But when it is negative, this is where it gets a bit tricky. Now, we then factorize by taking out the highest common factor. So this is how we can simplify a complex expression and use simpler methods to deal with it. Again, factorization step 2. Okay, I'm just going to highlight the steps here. We take out 3x, that's the highest common factor. We end up with x plus 3. Minus the highest common factor here is 2y. So we then have x plus 3. Now, this becomes nice and easy like that. Again, we look and see this bracket is the highest common factor between these 2 terms, this being the separation. So what do? We take out the highest common factor yet again for the last time. Usually factorizations end with factorizations if we are only factorizing. But when we solve, we then take it a step further. So you will see that it's just step 2 recurring. Now this is common. We take it out. So this is x plus 3 into what remains is 3x minus 2y. Now we cannot factorize further. This is done. So sometimes the question may say factorize fully. Great. So when we first factorized each one by taking the highest common factor, that's the mark, and the second one. But please, guys, check the solutions. And in this case, we expand and see if we are going to get the original expression at all. I'm going to dash this because it may not go there, depending on whether this is a perfect one. Let's see. X times 3x is going to be 3x squared. X times minus 2y is going to be minus 2xy. 3 times 3x is going to be 9x. 3 times minus 2y is going to be minus 6y. And so it is perfect. So we can now move on, knowing that we have done justice, because it's easy to think this is good only to find that it doesn't go back. And therefore, marks get lost over very simple questions. All right, good. Let's do question 2.2. We now need to simplify. Again, the 3-step becomes very important. In fact, it is important in every calculation or determination that we end up doing. So we've got 2.2.1. We now have m squared minus 64 divided by m squared plus 8m. This is divided by m minus 8 divided by m. Okay, now remember guys, before solving any expression, you explore it, you inspect it. Now we see that this is m squared, 64 is a perfect square, so this is a difference of 2 squares. So what does this mean? Factorization of a difference of 2 squares. Since this entire thing is a single term or an expression, we will then write equal to. We then do the difference of 2 squares nicely and divide here. Okay, let's start there. We take the square root of the first term and we write it in each bracket, and then we take the square root of the next term, we write it in each bracket. Now the sign is going to be the original, and then the other one is opposing. That's how we factorize a difference of 2 squares. So basically step 2, which is factorizations. Here on the denominator, we can take out the highest common factor. We end up with m plus 8. We can flip the sign. Remember, division and multiplication can be looked at as one. But whenever we convert this to multiplication, a fraction flips. We get m over m minus 8. Now the games begin. We see that this factor will divide that to 1. And 1 is as good as invisible. This m will divide that. We call it cross divisions, if you will. And we also see that that one will also take care of that one. All right, as long as one is on the numerator and the other one is on the denominator, and we're multiplying, because we would have multiplied the numerators and the denominators, and these things would just easily divide, but we don't want to wait. So this is 1 times 1 times 1, that's 1. Divided by 1 times 1 times 1, that's 1. And the answer is 1. Nice and easy. Okay, very easy stuff. Now guess what? We then did step 2 here, factorizations / step 1. More like a reverse operation, because we changed division to multiplication. We're just undoing that, inverse operations. So that's essentially what we did. So how many marks are we scoring here? Factorizing the difference of 2 squares, it's a mark. Flipping that, when we change the sign, doing reverse operations, that's a mark. Taking out the highest common factor there, that's a mark. And the final answer, that should be the 4 marks on offer. Okay, easy stuff guys. So please know how to simplify and make sure it's good. In fact, I always check my solutions. Let me not be a hooligan. So let's just assign a value for n. And then once we do so, we put it back into the calculator this time. So let's just do it nicely. So we're going to have m is 2, we square that, minus 64 divided by, again, 2 squared plus 8 into 2, right? Right, and then we say that whole fraction is divided by 2 minus 8 on the numerator. Oops, wrote this one wrong. 2 minus 8 divided by just 2. So if I don't get 1, I'm dead. So I'm getting 1. So can you see, before you move, you check that this is good. And there's always a way. Unless a question is really strange, then you hold on to things like substitutions and manipulations. Because there are some questions like that where you wouldn't know how to prove it if it is true, but then you just hold on to the steps that you followed and make sure they are perfect. Okay. 2.2.2. Now we have to deal with this exponential expression. So this is 2 to the exponent n minus 1. Please guys, know that the correct way to read this is 2 to the exponent n, or 2 to the index n minus 1, or you can say the n minus 1 power of base 2, not 2 to the power n minus 1. It will catch up with you when it matters the most. The grade 12s of 2025 who wrote the supplementary exam found out the hard way. So a lot of misnomers are common to all of us, but then they hurt when it matters the most. So you don't want to be in that situation. Rather say things carelessly, knowing exactly what they stand for. At least that's better. So be comfortable saying things wrongly, knowing the right thing, or else it will catch up with you and you're gonna cry. Sorry for that. So this is 2 to the exponent n minus 1. Remember, once the base is a prime number, we don't really tamper with it. 8 is not a prime number, so we can change this. This is 2 cubed, all to the exponent n plus 1. Okay, this is divided by, we're using laws of exponents now. 16 is 2 to the exponent 4, all to the exponent n. All right, we continue. Now that we see, we first sort out those brackets, because remember, order of operations, we handle brackets. 2 to the exponent n minus 1 times. Now the 3 distributes to those terms on the exponent. So this is going to be 2 to the 3n plus 3, all divided by 2 to the 4n. That one is easy. Now once we get to that, we see all these bases are the same, so we use our exponential rules. So this is going to be us, first the numerator, we're multiplying powers with the same base, so we will add the exponents. We just keep the base. So this is 2 to the n minus 1. Then we add the next exponent, which is 3n plus 3. Now hold on. This would be now powers with the same base are being divided. So what do? We then take the base. The exponent on the numerator must subtract the exponent on the denominator. Good, so I'm just doing this in one big step to avoid unnecessary stress. N plus 3n is going to be 4n and minus 4n. That's 0. Minus 1 plus 3, that's 2. So we end up with 2 squared, which we can simplify to 4. Okay. Nice and easy. Okay, now this is all good. Again, if we look at it, what steps did we use? Well, we used laws of exponents, or should we say logic, whatever. It could be anything, but step 3 here was in the house. Secondly, what did we do? We then do brackets, which is BODMAS. This is step 1. From there, we went back to the laws of exponents. When we multiply powers with the same bases, we add exponents. And when we divide powers with the same bases, we subtract exponents. And from here, it led us to ordinals, O or E for PEMDAS. So this is step 1. Now what do? We just go forward with it. We get a 4. Nice and easy. So we got our business in check. So I'm just trying to highlight this, guys, so that you are aware that this is what we do. Now, how do we score marks? When we change these bases, that's how we score the marks, right? Right. Usually, the order of operations used in the forward direction, we don't really get a mark per se. But using the law of exponents now to try and make sure that this simplifies into one thing, it's good. And the final answer, because that's what we're looking for, right? Great stuff. Nice 3 marks. Not a big deal. How many marks are in this question? Easy 9 marks. Of course, guys, practice as many of these kinds of questions. Try to gravitate towards the higher order type questions so that the easier ones become just amashwam yabo. And this is how you can really save a lot of time. Because for those ones, you don't have to think too hard because your brain is already functioning at a higher level, right? Again, folks, we don't just shy away because we won. We check. We say let n be. Just choose a small number that we can handle. Because if you choose a big one, you'll end up evaluating infinity and you end up with a math error. And you won't know what happened. So we go there, say fraction button 2 to the exponent 2 minus 1 multiplied by 8 to the exponent 2 plus 1. Ensure that the substitutions are good. 16 to the exponent 2. Right? Let's see. I'm getting 4, so it means all the gymnastics that we performed were on point. We didn't break our necks or sprain our ankles. Nice and easy. As you can see, guys, we're just cruising here. So there's nothing that says struggle in a question paper like this. Of course, if you attend class, you practice enough, you study enough, and of course, you discuss with your friends, because if you keep this to yourself, it will always haunt you when mistakes come. But when your peers share these kind of issues and they show their frustrations with the subject or the topic, their difficulties, by explaining, you're actually strengthening your resolve as well. All right, guys, we're not going to say too much. We'll go to question 3. Question 3 says, we need to solve for the unknown variable in the following, okay? So we have 3.1. We've got a plus 1 into a squared. Plus 2a minus 3 is equal to a into a squared plus 3a. Okay, so this time, what do we see? BODMAS. So technically brackets off this time. Like the grade 8 type, we don't normally talk of brackets ordinals, but yeah, the brackets must come off. How do we do it? FOIL method or distributive law. A times a cubed. A times 2a, this is 2a squared. A times minus 3, this is minus 3a. 1 times a is going to be plus a squared. 1 times 2, this is going to be 2a. This is going to be minus 3 is equal to a times a squared is a cubed. Plus a times 3a is going to be 3a squared. Okay. Now immediately we see that a cubed is the same sign on either side of the equation. So it means when we transpose one to the other side, they will literally cancel out. This is a proper cancelling. Now we look again, 2a, right? 2a squared, sorry. Plus a squared is going to be 3a squared. Then it will cancel 3a squared on the other side because they share the same sign, same value. Like terms, when you transpose, they go out. Then we've got 3 minus 3a plus 2a. This becomes minus a. Minus 3 is equal to 0. Transpose a to the other side to solve for a. Therefore, a is equal to minus 3. Done. Okay, so again, folks, if you just want to trace the 3-step approach, you will see that we started with BODMAS by taking the brackets off. This is step 1. From then on, we used like terms and what. This is step 1. And from then on, we just transposed, which is just perhaps more or less step 1, if you think about it. So here, literally just a step 1, and that was it. Okay, all right, okay. So, how many marks? Oh, 2 marks, 3 marks. Wow, why? Okay, maybe expanding the left-hand side, expanding the right-hand side correctly, and solving for A. That was it. Okay, now guys, I'm not going to highlight the 3-step approach anymore. I'm sure you can see its utility. So your job as a student is to then try on all the solutions I'm going to show you. Trace the 3-step approach. Where did it apply in our solutions? This way you become very familiar with it, even in a second nature kind of way, so that you can just do it in a split second without even thinking about it. Because when I solve, actually, when I'm chasing time, I don't even think about what I'm doing. I just know what to do. I can even guess the right way or the right path without really going through a lot. But when I'm demonstrating this to people, I tend to be a bit anxious. So I take time to ensure that when I'm showing people, I'm not showing them crap. Although it almost always finds its way into your attempt to do the right thing. Yeah, sometimes it's just, I guess it's just being too aware of the weaknesses of my mind. Now 3.2, we've got the normal quadratic trinomial, which is our famous one. Here we can easily do this by inspection. Now guys, I don't know, in grade 10, I don't think you do the quadratic formula. And for that reason, most of the quadratics, if not all, I would believe all quadratics that you will ever come across in grade 10 are all factorizable. You start to get ones that you cannot factorize in grade 11, and they continue for life. All right, okay, all right. Now let's have a look here. How do we solve for this one? Easy. We just factorize this thing. So this implies, in an equation, we do implications. So we can have 2x and x. Now, since we want this one to be positive, so we know that this must be plus 3 and minus 1. So, sorry guys, I caught flu. So it's starting to show its face and I hate it. So of course guys, I'm not gonna go through the steps here. I know you're grade 10s, you're supposed to show everything, but yeah, I'm not the guy who's going to teach you things that are not effective. If you already don't know how to separate these factors, you are dead, okay? So this means x is equal to minus 3 over 2 or minus 1,5. Oops. Or x should be 1. Again, folks, what do? We check these solutions. I even forgot for 3.1. We need to check them. Okay, first of all, let's assume we got it all right. Factorization, that's step 2. Then BODMAS follows when we deal with brackets. So these solutions should be, how many marks there? Wow, 2. Aibo. Means the factorization is not given a mark. I feel like it should be given. This is not that easy as one may think. So the examiners are being mean here. This cannot be. In fact, this is the one for just 2 marks. There's not a lot there. But this one definitely for 3 marks. So can you see guys, these are just the show that the coordination process is bad in the country. Because people don't even think about what they're doing. Why would you give more marks for just this thing? This whole thing should be just 1 mark and the final answer, because I mean, that's the easiest algebra you can do. But here it's a bit technical. To factorize is a skill. Then to deal with this is also, you know, some kind of a skill. I think the solutions do matter as well as the technique in arriving at them. So it just tells you, man, people are just not doing their jobs. I'm sorry to say it, but it just has to come out so that they can know Maybe they will correct it, but a lot of South Africans are arrogant. They don't like to change things just because it's somebody else who pointed those things out. They're not humble at all. And this nonsense of not being humble destroys the nation, because we end up with people who are big-headed but who are literally empty-headed at the same time. Amanzi nje kwezanhloko yagonjoza nje ugonjo. Hayi mana mina ndiyaxolisa kodwa ubani ba-offended because it's not directed to you who's listening. It's to anyone, including myself, by the way, because I'm also South African, right? So when I'm saying South Africans, I'm also putting myself in that same bucket of hot water. I'm going to boil along with everybody else. I'm not saying I'm out of that boiling pot. No, I'm putting myself in fact, head first. All right. Yeah, I'm the brave one. All right, guys, let's check our solutions. If we put this thing in there, we get 9/4. 2 takes 4, we remain with 2. So we end up with 9/2, right? 9/2 is essentially 4,5, right? Right. And this is 1,5. So 4,5 minus 1,5, this is going to be 3. 3 minus 3 is 0. So this solution holds. 1 in there, it's going to be 2 plus 1, that's 3. 3 minus 3 is 0. So the left-hand side equals the right-hand side. So this solution holds. Let's put minus 3 in there. So this is minus 3 plus 1, it's minus 2. Then we come here, it's going to be 9. Minus 6, that's 3. 3 minus 3 is 0. 0 multiplied by any number is 0. So left-hand side is 0. Put it in here. It's going to be minus 3 on the outside. Inside, it's going to be 9. Minus 9, that's 0. 0 multiplied by any number is 0. So the left-hand side is equal to the right-hand side. So we know. We don't need a conviction of any memo. As you walk home, you can even gauge how many marks you got, because you understood every process and you checked most of your solutions. Of course, you may not have time to check all of them, but check most of them, especially easy marks. They are the easiest to botch. Hard ones, they already demand high attention, high alertness from you, and you mind your steps as you walk through. So usually those ones, it's either you get it or you don't, but most of the time mistakes don't creep in unless you relax once it starts to show that, okay, I'm going that way. But most of the time, difficult questions, usually a student who can handle them, they do them well. But the easy ones, mistakes are always there, because when you do it, you're like, I know this. And one small mistake will cost you a fortune. Don't leave questions where you can check answers unchecked. It's a crime, okay? So 3.3. Now we need to deal with this inequality, okay? So this is 2x minus 1 less than 7 greater than or equal to 3. Now, folks, a question like this needs to be split in your mind, not here. In your mind, this means 3 is greater than or equal to 2x minus 1, right? Or 2x minus 1 is less than 7. So this is a system of linear inequalities that have what we call an overlap in terms of the feasible region, okay, that they span. So when we solve this, we just transpose 1, we get 4 less than or equal to 2x. Remember, when we transpose, nothing happens. We divide by 2 throughout, but this 2 is positive, so it means the inequality remains. Here we transpose 1, again 2x is going to be less than, when we transpose it's 8. Sign doesn't change when you transpose. We divide by 2, but since 2 is a positive number, the inequality remains the same. So this is what we have. Can you see? Less than 4, greater than or equal to 2. So we combine these two again. We get x is less than 4, greater than or equal to 2. So usually this is how we prefer to present this answer. And you will see this is very popular in grade 11 and 12. So this is someone trying to actually train you guys in knowing how to combine inequalities. I have never seen one that is put like this. For example, I have never. So please don't do it. Don't do it. This is not acceptable. Although it looks okay, don't twist mathematics. We don't read a book from the left to the right. Okay? Please think about the standards sometimes. They have a standpoint at times where we cannot do less because anything else would be inferior to what is standard. Sometimes the standard is the highest level you can reach of a certain way of doing things. So please don't think because something is standard, it is the least you can do. Most of the time it is, but sometimes it is the only thing you can do. So this is why teachers need to really teach in class and stop just pushing, I don't know what they do, but they need to teach. And this thing needs passion from the teacher. It needs dedication. It needs diligence, precision. Okay? Not haphazardness, not disorganized behavior there. And not just, this lax way of doing things. Instruction needs a teacher to stamp some authority in class. You cannot go into a class and become a friend of students. You laugh with them, you recite recitations like in kindergarten. That's ridiculous. You cannot teach maths like that. If you start teaching maths like that, you're not going to get those kids anyway. Yes, they may pass, but they're not going to get anyway. And that's the bad thing. Because when they get to serious courses, higher order levels of study, there's no teacher who's going to hold your hand. You are lucky if you find one. But I can tell you, there's always a catch with those. If you find one, there will be a price to pay on your part, and you may not like it. So start assuming independence now, but the teachers need to facilitate that by not being that friendly, but being okay, of course, welcoming and approachable. But they should not be your friends. You should not joke around them. You should not do however you please in front of them. Tina, when we see our teachers would mind how we are sitting, what we are doing. The boys will smoke. They would throw away their cigarettes. They would not continue to smoke with teachers walking around. Okay? But you guys nowadays, where you even start calling them names in front of them. Yes, we did call our teachers names depending on what fitted them best. But the reality was we never said it while they could hear. That was some serious punishment. So teachers command authority. At the same time, don't be nasty to kids. There were teachers I found in Gauteng who would just be insulting kids, saying really stupid things. You cannot be exchanging insults with kids. It's just wrong, just bad. You are not a teacher if that's the case. Kids need to not even dare say stupid things in front of you. Okay? Yes, a laugh every now and then, it's okay, but that must be decent. Any indecency is bad. All right, folks, enough of the rants. Now, what we do here, I just wanted to show these guys this thing split, but here we solve it all together. So we transpose 1 to this side. It's going to be 4 greater than or equal to 2x less than. We transpose the 1 also to the other side. We get 8. But think of it split if you can't handle it. But remember, this is what is expected. Then we divide throughout by 2. We get 2 here. But the sign doesn't change, as well as this one. And we are done. As you can see, when x lies in between two values, we always put the bigger one to the right and the smaller one to the left. Okay? Because this kind of nonsense doesn't make sense. Okay? X cannot be greater than 7 and be itself less than 3. You understand this? So this is bad. This is not right. So don't twist inequalities ever. 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 Okay? Don't do it. Let's say this was a -7, for example. do not do this. X can be smaller than 3 for sure, right? And can be less than -7. But we can't write it like this. We don't read a book from right to left. So this has to be rearranged, that x is less than or equal to 3, greater than -7. This is the acceptable way. This is the wrong way. Please never write any inequalities like that. Yes, it's okay, but it's wrong the way we write it. That's not how we write a book. Okay, so certain things are just not to be toyed with. If you do so, you are dead, okay? Believe that. Now, we're going for how many marks here? Just 2. Okay, great. So usually this notation is enough for this, but we need to see the steps anyway. But of course, this one to check, x between 4 and 2 included, we can put a 2 where x is. For example, this would be 4 minus 1, that's 3. Can you see 3 is indeed equal to 3, and it is indeed less than 7, so this holds. 4, put a 4 in there, this is going to be 8. 8 minus 1, that's 7. That's going to be a 7. So 7 is not less than 7, huh? But 7 is certainly greater than 3. So this solution is scary now. 100% scary. 100% scary. 7 cannot be less than 7. Not at all possible. So do you see, guys? Hey, some questions, if you don't check, I promise you folks, it's so easy. Oh, by the way, I made a mistake. We cannot say x is equal to 4. I almost went for the wrong thing. I was going to slash this. Don't slash it yet. We cannot substitute 4. It should be less than 4. So an integer less than 4 is 3. No, this is 6, 5. 5 is definitely less than 7. Definitely greater than 3. So yeah, this holds. Okay, please be in the habit of checking and making sure that you double check and triple check and quadruple check. Now we're solving for x simultaneously, x and y simultaneously, so this is not bad. So we've got 3 to the x plus 2 is equal to 27. Now we look at the base. Can we express 27 as a power of base 3? Yes, we can. So this implies that we've got 3 to the exponent x plus 2 equals to 3 cubed. Now same bases, it means the exponents are equal. Right. Therefore, our x is 1. We can say therefore, or maybe let's not therefore. Let's go like a then. We know that 2 to the exponent y is equal to 4 to the exponent 1 plus 12. We substitute straight away. This implies that 2 to the y is equal to 4 to the 13. Okay, 13 is quite a small number, so there is a value to this, but it's quite huge. But now we know that 4 can be shown with its prime base. Not 4, but this is y. Ooh. It's going to be 2 squared times 13. So this implies that 2 to the y is equal to 2 to the 26. Okay, 26 is not too big. We're not at infinity, so this has a value as well. But at this stage, we don't care. We know that y is indeed 26. Okay, so that's good. Sorry. So this was question 4. Sorry, this was for 4 marks. First of all, x and y are good. Changing this dude was key to solving x. And here, I don't see so much, but perhaps substitutions is probably the main step, because this is more of a repetition of that. Okay, so easy 4 marks, guys. Again, check the solutions, please. We go back and say, okay, when x is 1, let's see, this is 1 plus 2, that's 3. 3 cubed is indeed 27. So this one holds. We come here to y and say, okay, all right, so this is going to be 4 to the 13, right? Let's see. Let's say 2 to the 16. What is it? It's going to give us a big number, right? 2 to the 16, but it's evaluatable. So this is 600. Wait, this is 65,536. So 65,536. That is 2 to the exponent 26. No, I said 16. Big mistake. I was surprised this is too small. Okay, this is 2 to the exponent 26. Yeah, man, it looks like it now. So this number is 6710884. Now, how do you read this thing? This thing is 67,108,864. Please don't be someone who cannot read up to a zillion. All right, let's see if we're saying now 4 to the exponent 13, because this is what we get. Same number. So this means left hand side equals right hand side. Now we don't care what somebody else has in the memo. We know we are right. If the equation is balanced and we didn't do any crime, we did not distort our expressions, we are home free. So can you see, guys, you can walk away from this exam knowing exactly how much you got without seeing the memo. So if the teacher tries any tricks, you know what you did, okay? And you can challenge them, right? Sometimes you've got to do it because, sometimes they do it deliberately because they see, this one, too clever. Now we said yesterday he's dumb. Now if he shows up topping the class, it looks like we misjudged. Remember, some people are not so good at accepting that they were wrong about an impression on somebody. Now, let me make an example of myself. When I got to Gauteng, must they take us lightly, those of us who come from the EC especially, because I'm from the EC too. So when you get there, but track, one of my teachers was just doing it, jokingly, because her husband was from here, so she was just saying that, just for the vibes, not necessarily meaning it in a bad way or in a bad light. But the others would be like, you came here yesterday and now you think you're clever and this and that. You know what I noticed is that my maths teacher, especially geometry, I knew that was my strong point. Of course, algebra, I never really counted it as a challenge at all because, that's the pap and flace of maths. But geometry, many didn't really like it. Whenever they did geometry, they cried. So I was like, I know geometry, I would be proving congruency and all these things. And that guy would just mark me wrong. Even my grade 9 teacher, actually. For some reason, he would just mark us wrong. And I'm like, what is wrong with this guy? I was teaching people maths, man. I could do maths especially with these algebraic expressions. I remember I was doing grade 7. He would give me questions that, grade 8s were struggling with, especially his best in grade 8. I would solve that thing if it is related to what we are studying in grade 7. So I was kind of that guy, man, who could think ahead. Even my maths teacher back in grade 5, which is standard 3, we called it standard 3. I remember we used to be combined with the standard 4s because we were taught by the same two ladies. The one who actually taught me grade 1 and grade 2, which is sub A and sub B, she went and advanced herself. By the time she came back in 98, she was teaching standard 3 and 4, and I was there. I remember she gave us a question on long division, one of the longest you can ever imagine. All the standard force couldn't handle it. Yes, it took me time. So I saw them going up and going down, going up and going down. Remember at that time, you would calculate and then go to the teacher's desk and then show your answer. And then she would be like, no, thank you, Boza. Try again. Everyone, thank you, try again. Until the whole class was exhausted. Of course, I think I went before all the people were done. And I went there, and then she just looked at my face, and then she shook her head. She was like, man, you can calculate. Goodness, how the hell did you do this? And I'm like, man, you taught me how. She was like, but come on, man, the standard fours are choking, and they are all done. And you just sat there, and then you were doing this, and you come back, you have the right answer. Like, hey, man, yeah. Ingathi wena uyiphethe le nyaka nyana bese ndiqonda namba ndiyiphethe nyana. So now 5 utitshala wethu uMphomane. Oh, that guy was hard though. Mntate Mphomane, nari kuyawutabula. But then I kind of knew how to deal with him, because when I don't know the answer, I'll just raise my hand. I knew he knew I would be the problem, so he wouldn't ask me first. He would start with the others. And of course, in those days, if you don't get it right, you get a lash, right? So I just have my hand up, and I used to like the corners. I was a naughty boy anyway. I'd like to sit in the corner, right at the corner. So I was just seated there, and my hand was up, and then he would be going around the class, handling his gushas, his sheep. He used to call us his sheep. I would do it and do it and do it. And then someone somewhere would answer, and guess what? Save me, because he wouldn't come to me first. Hey, but it happened one day. It was all about the thermometer. So when it's hot, it expands. When it is cold, it contracts, we say. We don't say it decrease and increase. No, it expands and contracts, okay? So I forgot the expansion part. You know, most the English at those days, I mean, come on guys, the slung was not the slungering. It was not slungering at all. We were being slungured by the slungu, eh? So I didn't know how to speak a bit, but come on, my comprehension was not so good. So if you didn't remember, most of the time it was very hard to compose it. But by the time I was doing grade 10, I was able to compose answers, even if I didn't understand fully, or at least remembered from the book. But just combining things like words and stuff, it would be easy to kind of get somewhere close. But I tried to remember, man. I was like, it's not coming. And by the way, at those times, you needed to rely more on memory than just, composing the word. Now, remained two of us, a girl and me, and that girl was clever. Some Kelisiwa was a bomb, She was a threat, by the way. And the threat was just right here. Remember at the time they made us sit in groups. It was a stupid OPE thing, just started, but then they couldn't implement it, so we went back to the standard way. But we maintained the group sitting. So one of the biggest threats was just next door, my group mate. Oh, that girl was something else. The only thing I knew I had a shot at her was maths and physics. The rest, I was just crying underneath her. And as a result, she would be number one in class anyway. Because, she would hit most of the subjects. And do very well, of course, in maths and physics. Of course, I would be king. But, yeah, I did poorly with the others. Okay, not good enough to challenge her. Although I was a very close threat, but I was not really that much of something that could make her not sleep at night. Now it was the two of us now, the other girl though, from the other group. And then he was like, which one do I choose now, guys? Because these ones are problematic and I must chow one of them. I'm chowing one of them. But now the problem is that they can save each other because, these ones. And then you'd be like, okay, the girl I don't trust. And then you would go to the girl. And when it gets there, and then she stands up and they were like, oh, sit down. Come to my desk. And when it comes, I would stand up looking at him in the face, of course. And be like, no. You're going to save my ship there. And then you'd be like standing there, not knowing which direction to go. And then, of course, his senses kicked in. If anyone needs to be saved, it must be the girl. It was like, I'm coming for you, Poza. And you know what? I made the entire class laugh. Instead of crying, those who used to cry, they laughed because I just gave him my hand. I was like, can't tell it's a humble and I can't now he stopped asking me questions because he never knew when I know when I don't know. So sometimes I'll just leave my hand down and just give him this confused look in my mind, and then it would come for me thinking, finally I'm getting you. And then I just shoot the answers like, he would be like, I'm not asking that one. Until no one else answered. Anyhow, that's how I spiced my education, and I just made my teachers to have a challenge with me. Of course, a nice challenge, not a nasty challenge. So don't be nasty, man. Just make them remember you. Make them remember you. Even when I meet them in town, I mean, come on, it's been how many years? They left in 2001. Both of them, most of the guys, Mpomani and Mr. Manamoledi. He taught us history, though. They called it HSS. Some stupid... I don't know why people came up with that silly education anyway. But those teachers, they still remember me. Even if they see me now, they'll be like, that one. Then beza ngomadlebe because indlebe zami bezithe. Abantu ngathi sesikantovana, odle isweet ebhalwe indlebe enkulu. Then baba ngazo. Sesimamele izindlebe lezi yo. Ungazithathi kancinci. Madlebe, why dangerous, bafana bam, why dangerous, nani ke, nibe dangerous. Kodwa in a nice way, nibe nice danger, you know. Nibe lando ichilis, yabona ichilis uyidla usithi, imnandi kodwa yakaka, ifake ngolento. Yeah. Ningabi nice and sweet, umntavela anambithe. Into enambithwayo, kuzubuxoke emva kwakho. Kanti ayikaka. Because I'm not. Anyhow, let's get to functions, guys. This is another very serious topic for grade 11s and 12s. In fact, these tend to recur. So now we're given the graphs of f equals 2x squared minus 2. Right? This is a parabola vertically shifted only with the axis of symmetry at the origin. So this is good. Usually this is about what you can get. It's either not shifted vertically or shifted vertically in grade 10. You will not get the horizontally shifted one. It comes in grade 11 and 12, where we combine the shifts and even reflections for that matter. Then we've got g of x equals k over x. This whole thing just tells us we're looking at a hyperbola. Of course, k giving us the signature of what it looks like on the Cartesian plane. Of course, again in grade 10, you seem to be getting the vertical shift. Usually this was grade 11 stuff, but hey, it's here now. Because grade 11, we kind of put a lot of shifts and reflections there. All right, okay, so that's a vertically shifted hyperbola, but you can see it never gets horizontally shifted for grade 10s. I don't know if they would change their mind, but it would be unacceptable, I guess, unless the guidelines changed. Now, of course, we can see something that a here, what do we call? We call the coefficient of x squared, or the highest power there, a. And we can see that a is greater than 0. Now, when a is greater than 0, it tells us the parabola is concave up, and we call it a smiling parabola, meaning at the turning point we'll have a minimum value. But now with a vertically shifted parabola like this, we know that the minimum value is the y-intercept. So for the parabola, we know that at C we are sitting at -2. Great. And of course, we can work out the x-intercepts. This is going to be transpose 2, it's positive divided by 2, that's 1. Square root is plus or minus 1. So at A, we're sitting at -1. At B, we're sitting at 1. So again, guys, be quick about these kind of things. Using the concept of intercepts is very key for grade 10s. Grade 9, you just use a table method usually and check values that I'm going to choose x as 0 and see what happens, and some other values. That is grade 9, grade 8. But in grade 10, we should be talking about x-intercept, y-intercept, and know the shape from just the parameters of the equation. So that's fine. So everything is good. It's tying up nicely. But what about the hyperbola? Well, we know here that the vertical asymptote is when x is 0 because x cannot be 0. Remember, we don't divide by 0. So this is the asymptote. Okay, it never gets touched by the graph, as we can see. Second, we know that the horizontal asymptote should have been 0. But then if this is 3 over 2, it will mean that we are at 3 over 2 right there, where the asymptote cuts. That's as it appears on the equation. 2, we see our graph is on the second quadrant and the fourth quadrant. So it means k is negative. So k is less than 0. We know that when k is less than 0, this being the Cartesian plane with the origin there, the y-axis here, we know that the graph should be there and there. And we see exactly that here. So we know that k should be negative for this to make sense, okay? Now this analysis looks unnecessary. But remember, when you are practicing, these are the notes you want to cement in your brain. This is what you want to be able to spot without even thinking about it. You just see it and you know what it stands for, so that you don't have to worry about what I'm doing. Now I'm showing you the mechanistic way of going about business so that you don't become careless. Remember, when you become a professional, guys, you need to pay attention to detail. That's how you will win amongst your peers. Your peers always want to be shown by somebody else what to do because they just shut their brains for listening and looking. They just want to be shown, and that's it. They want to be free, but free in a very slavery way because they end up being taken for a ride by many issues in life. Okay, so being precise and careful, you will always win. Believe me when I tell you. So anyway, we are told A and B are the x-intercepts of f and C is the y-intercept, and we can see indeed this is where x is cut by the parabola f, and the y-intercept, this is where the y-axis is cut by the parabola. So we call the quadratic equation, the quadratic graph, a parabola. Nice. G of x is doing its own things and it's cutting there. We don't know where it cuts, but it doesn't cut the y-axis. Okay, good. So we don't have a y-intercept, but we do have an x-intercept here. We will work it out. That's a potential question, but we know that, well, it's going to be some x value, but the y value is 0 because it's on the x-axis, right on the x-axis. The x-axis is also often referred to as the line y is equal to 0. The y-axis is often referred to as the line x is equal to 0. So please, guys, pay attention to these kinds of things because these sometimes can be an issue when we get to reflections of functions on the Cartesian plane. Okay, we're told that d point minus 2 is to 6. There it is, point in the second quadrant. So how would you know a point is in the second quadrant? Because the x-coordinate is negative while the y-coordinate is positive. Now, the old mathematical texts, of course, you would know that the x-coordinate, we don't really call it the x-coordinate there. It's called an abscissa. And the y-coordinate is called the ordinate, okay? So again, when you read old text and the history of mathematics, you will just uncover a lot of things that have been long abandoned. And this abandonment of what this is in the past and how it is today makes us not to see a lot of things that actually matter. Because a lot of these things that we regard as not significant, it's just careless minds always looking for what is prominent and obvious, but those things are actually the ones that are useless. But the things that we choose to ignore most of the time are usually the things that actually matter moving forward. So be very careful. Always know your history so that you can know where you're going. Isn't it the talk in every village or in every society, in the world at large? If you don't know your past, how would you understand your surroundings now, your current state? And how would you even project into your future? You wouldn't, because it would be just ignorant all the way. Bump into problems every time you change a step, you move into the next level. But once you know where you're coming from and you know where you are, you would definitely know where you don't want to be and where you want to be in the future. And you're most likely going to be exactly in those areas. Avoiding trouble, but winning, if at all your goal is to win. So this is the idea, guys. We take it from the basics and we build up nicely while maintaining vigilance, like we are witch hunters. We take every clue like in a hunter. A hunter looks for every clue that there is an animal that just passed, and in this direction, if I continue, I'll find it. They can even be able to tell by looking at the weather. If there's a what do you call this thing? Inyawo kodwa xa listempekile mhlambe edakeni endaweni emanzi, they can already even tell how soon before they arrived was that put in. So they'll just look at the texture of the mud or the marshy area or even the sandy area and the wind, how it's moving. They can gauge, okay, this one probably maybe a few hours ago, and they can already gauge because you can know the behavior of these animals when they eat, how much of a distance they cover in an hour. I mean, if you are umuntu so loose, you don't need a second invitation to know those things. Because you can even gauge how far it may have gone. Of course, thinking about other issues that probably there's no people who passed by. There's no head of cattle or sheep that passed by. Maybe it may have scared this thing to hide. Even when it hides, it's better, because if you can tell that some people passed by not so long ago, definitely it's in hiding. And if it is in hiding, it's not far. But if no one passed, you know that, okay, the distance you would normally estimate, you may have to think about it being a bit longer, because now it's going to go as far as it wants to go. So guys, hey, mathematics is like this too. You see. The more work you do on the graph before you even worry about questions, the better you will perform. And the faster you will finish this question. I promise you. Don't worry about me taking long. Write down. Now a question that says write down, it means answer only, guys. Please don't start telling stories. That's the indication. But some examiners do write these inappropriately, because an answer only can only be a 1 or 2 mark question. You cannot have an answer only for 3 marks. Of course, that depends again. A 3 mark perhaps it's like a border zone, because some graph interpretatory questions can actually carry 3 marks for just an answer only. But you will see the answer will have 2 components to it. It won't just be a single thing. It's usually one thing and another, be it a restriction or an addition. But you'll never say one thing only, and that's it for 3 marks. Never. So, answer only. We need the domain of G. Now, G is the hyperbola. So, we know that the hyperbola G is only limited at the vertical asymptote. So, we have 4.1.1. We can just say X is an element of all real numbers except the origin. X cannot be 0. Okay? So, by stating the set and the restriction, 4.1.2. The range of f. Now, f is only limited at the minimum value and not limited above. Okay? So, we know that, okay, we can say y is greater than or equal to -2, while we maintain y must be an element of real numbers, except at the limitation, of course. So again, 2 easy marks. We need to state the set in which this y is found and the restrictions. Okay, remember that. Now we've got 4.1.3. It says we need to find the equation of the horizontal asymptote of g. It's usually that constant term or the vertical shift. So we say y is equal to 3/2. Easy one, mark. So 4.2. We now need to calculate the length of AB. Now we know AB is a horizontal line, so it's going to be the x value at B minus the x value at A. Although we calculated it carelessly, we now need to show this because the question says calculate. We need to show a calculation. There can't be a question that says calculate and then there's no calculation. Then that's not answering the question. Okay, please remember that. No matter how correct the answer is, follow the instructions. Excuse me for that. My throat is throating. I'm hungry as well. All right, so we can say, well, A and B is such that 0 is equal to, or perhaps we can just put it this way nicely, is such that f of x is equal to 0, which implies that 2x squared minus 2 is equal to 0, which implies that 2x squared is equal to 2, which also implies that x squared is equal to 1. Therefore, x is going to be equal to plus or minus 1. Of course, here we may need to show that we took the square root. Okay. Another student may just want to transpose back the 1, or even divide by 2 immediately to uncover the difference of two squares and factorize. It's really up to the student's taste of maths, really. Because what I believe in is that the first time you saw it is the best way we can go about it. Okay, nice. So what can we see here? We can say therefore x at A is minus 1 and x at B is 1. This is very good. We can say then AB is equal to x at B minus x at A. Because this is a horizontal line, we don't need to justify this. This is equal to 1 minus into minus 1. Therefore, AB is going to be 2 units. Okay, we need to state the units part. If it's not there, we lose a mark for the final answer. Remember that. Please, for your own good, trace the 3-step approach in all the other solutions I did not highlight in, just so that you can familiarize yourself with how useful this thing is. And by the way, most of the time we do it second nature style. All right, so substituting 0 there is key. Right. How many marks? 3. Uncovering these x values was key, specifically for the 2 points and the answer. Okay, I think that is the best way. But again, the marking guidelines are a better guide for this specific paper. But don't worry about it. As long as you know the areas where marks are scored, and whenever you solve a problem, you ensure those are covered, especially for questions where you are not so sure of the answer, and perhaps where you don't even get to the very good answer. Minding the earlier steps when your brain is still informed is key, because you might score some decent marks there. 4.3, we need to show that k is equal to 9. Now this is wrong, because the shape is saying k must be negative. Because if we look here, there's no minus k, it's just k over x. So k cannot be a positive number. If perhaps we had minus k here, yes, we could say k must be 9, because that negative would be appropriate. But this point here is wrong. Again, probably it's an honest mistake, but it just speaks to the fact that nobody checks what is written. Of course, I also have that fault, but because I don't have someone else proofreading my work before it's published, and I don't have the time, folks. I'm a busy man, so even doing these videos is really killing myself, to be honest, because I'm actually falling behind on my things that I have to do to try and cater for you guys, because if I don't do it now, I'll never have a chance again, because I will go AWOL very soon. So you better make sure, guys, you learn these things so that even if you don't see my channel ever, you never know what can happen to it. You know, with these algorithms and stuff, there's a lot of things. Sometimes YouTube just decides to hide it because you can see they're just doing it like that. So there are some guys I no longer see anymore. And all of a sudden you'll see that, they're still there. So YouTube is bad. As good as it is, it's very bad. So your best is to subscribe so that you don't lose. Every time there's a post, you're not going to miss it. But if you think you're just going to see it, you may not, and you might just miss out. Anyway, however you decide to do that. So we know that k technically must be minus 9, not 9. So the sign must be negative. Right. See, with understanding, you will not be fooled by this and be like raising your hand. Sir, I have a problem with this question. You just know, because your analysis is good. It means you study. You don't just read, you study. You practice, you understand. Here you won't be fooled. You'll be like, I know, made a mistake. I'm going to do the right thing. Because there's no way it's going to be positive for a graph like that. You understand this? So those are the notes you must have in your mind. Anyway, we can say g of x is equal to k over x plus 3 over 2. Now through point D, which is minus 2, is to 6. 6 is equal to k divided by minus 2 plus 3 over 2. Okay? Now we can see 2 is the common denominator, so we multiply by 2 or minus 2 throughout. It doesn't really matter what we choose to do here. But fact of the matter is we multiply. Let's just multiply by just 2 and avoid trouble. Again, it depends on how strong you are. Some may choose to transpose this, handle the numbers, then cross multiply. That's still okay. There are many ways of killing a cat, guys. So if you multiply by minus 2 there, get minus 12 is equal to, no, did I multiply by minus 2? No, by 2. We get 12. And then we multiply by 2 here, we get minus k. Then here we get plus 3. Therefore, transpose k to that side, transpose 12 to this side, it's going to be minus 9. And we know this is correct because we understood the shape of the graph and we understood exactly how k should be. So how many marks are we scoring here? Just 2 marks, of course, substituting the point and the correct answer. Don't give the wrong answer just because the question paper is suggesting a wrong answer. 4.4. We now need to write down the equation of the line of symmetry of G with a positive gradient. Again, it says write down, meaning answer only. Now remember the axis of symmetry is always going to be y is equal to x and y is equal to minus x. Now with the vertical shift, we're going to add a q. So this is what we need, this one. So we know that it's going to be y is equal to x. Now q, remember these graphs pass through the point of intersection of the asymptotes. It's already on the y-axis, so this is plus 3 over 2. So this is easy, no need to calculate the c. All right, good, 2 marks for the gradient and for the y-intercept. 4.5. We now need to write down the value or values of x such that this is the case. Again, the question that says write down means answer only. 4.5.1. We are saying g of x is greater than f of x, meaning for the same x value, the graph of g must be above the graph of f. Now we need to read our graph from left to right, guys. not any other way. Now let's highlight how we're going to do this one. Alright guys, so as we read from the left to right, we can see that the graph of G, before this point of intersection, the graph of G is below the graph of F for the same X value, right? So this is not correct because this one is suggesting G must be above. Here they are equal. So it's not included, so it's out. Now, when we say a point is excluded, we just put an open circle like this, okay? And then what do? We move forward. Now on this segment, can you see G's Y values are above F's Y values for the same X value. So this is good. We'll take that. But remember, the asymptote cannot be included, as well as that point of intersection, because this is not included too. Then as we move past the y-axis, we will see that F is above the graph of G for the same X value. So this part is not accepted. So how do we construct our answer? We can say X must be less than 0, because 0, remember we're talking about X values here, X values, but it can be greater than -2. That's it. That's it. So this is good. Can you see? We write it this way. Please don't find yourself writing 0 greater than X greater than -2. This is wrong. Don't do it. Technically it's correct, but that's not how we write our answers. Think of yourself writing a book. You will never write a book in reverse. Otherwise nobody would read it. So you don't need an explanation for why this is wrong. All right, we are looking for when both F and G increase as X increases, okay? In fact, this one is too much. This is not necessary to state. I'm just saying it's a comment, okay? Don't say it should be removed. This is just a comment from me. Just say for both these ones are increasing. We don't care about X, okay? Because if X decreases, it means we're going to the left. And remember, this is the only way we read a book. And that's the only way we read any graph as well. We read it from left to right. So whenever X decreases, it would mean we're reading it to the left, and that's incorrect already. So this is why this is not necessary to say as X increases. It's absolutely unnecessary. Now, when we say a graph increases, it means we're talking about that graph holding positive gradients. Now, for curves, we draw tangent lines instead, because a gradient is a gradient at a point. It changes every point to the next. So if we draw a tangent line here on this hyperbola, just on two areas, just to see what they look like. So tangents there are actually positive. Of course, this is much gentle, this is steep, this is very steep. So those gradients are positive, even if we draw them on this side. So you see, knowledge of geometry as well is key here. So can you see those tangents are all positively sloped? So this means when A, or should we say when the numerator of this first fraction is negative, the graph is literally positive. I know some people call it negative graph, but it's not actually, because look, you can say negative because the gradients it registers are negative, but this one, the gradients it registers are positive. So this is actually a positive graph, but only when K is negative, or should we say A is less than 0. So these ones are positive. So basically this graph is increasing for all X values except the asymptote, right? From left to right. Remember, we never read from right to left, but left to right. Now we're done. This one has positive gradients. We can just indicate. Not positive Y values, but positive gradients. Now let's draw tangents for the parabola. Of course, the parabola always has both negative 0 at the turning point and positive gradients. It always works like that on a parabola. So again, here we will see that this is negative, this is 0 at the turning point, this is positive on that arm. So the question says, these ones must be both increasing, meaning for the same range or domain of x values, the graphs must be both increasing. And we can see these graphs are increasing for all x values greater than 0, that asymptote. Because we want it when both of them, not just one. So we can say safely here, x must be greater than 0, because we cannot include 0. This is an asymptote for the hyperbola. So we cannot include it because we want it for both. Now all these other x values to this side, we see that the parabola has positive gradients, not y values, because even immediately after the turning point, this still has a positive gradient. And this one too. Even if it looks a bit level, it's not exactly level. Alright, so this is why, guys, this is just 1 mark, because I mean there's nothing to it. It's just technical in nature, that's all. 4.6. We are now to describe the transformation of G to H. Okay, anyway, guys, you are introduced to transformations from grade 8, 9, so to speak. So, yeah. So, transformations is something that needs to be known. And, of course, these transformations are what? It's either it's a translation or a reflection. And reflections, we've got 3 types. Translations, we only have 2 types. Now, this is for students who study. Students who don't study, of course, we only deal with 2 types. Let me not say there are only 2 types, but only in high school level you deal with this. We don't deal with rotations and stuff as yet, unless I'm not sure. Translation is either a left or right. Okay, maybe we can say left or right, but in essence it's a horizontal shift or a vertical shift. A reflection can be about the y-axis, which is a horizontal reflection, or about the x-axis, which is a vertical reflection, or about the line y is equal to x, which is an inverse. Okay, those are the reflections we handle at high school level. So now let's analyze what is happening here. What we notice is that, well, there's a 3,5. Mind you, we had just 1,5. Now 3,5, it means we added 2 to 1,5. So we had 1,5 plus 2. That means we added 2 units. So this gives us a 3,5, okay? But now this one was positive. All of a sudden this is negative. So what happened here? Most likely, we did a vertical shift up by 2 units, and then we did something. Remember, k was negative. It's supposed to be minus 9. All of a sudden, this is plus 9 over x. So this means we did 2 reflections. One, we did first, how can I put this? Okay, now there's 2 things. Which one comes first here? I think we have 2 options here to think about. It's either we start by saying we shifted this up by 2 units to get to 3,5, right? And then we vertically reflected this graph, or we should say it was a reflection about the x-axis, because first we know that g of x was equal to minus 9 over x plus 3 over 2, right? So in this case, if we add 2, meaning a vertical shift up by 2 units, we will end up with minus 9 over x plus 4,5, right? Sorry, 3,5. Okay? Because this is 1,5 plus 2, which is 3,5. Then when we vertically reflect, we're going to say now h is going to be minus f of x, right? Is it? No. It's g of x. It's going to be minus g of x plus 2. The notation is failing me now. Is minus g of x plus 2. But now we put this in brackets so that this affects everything. So we know that we're basically multiplying this by minus 1. So this becomes now positive 9 over x minus 3,5. I think this is the one. Okay? So one can think of this as the graph of g first vertically translated up 2 units and then vertically reflected. Let's start there. So we can say here h is the graph or function, or let's just say is g instead of saying the graph, because this is for both graph and function, is g vertically translated, okay, let's just say vertically shifted up by 2 units and then vertically reflected, or one can say about x-axis. Either say vertically reflected or reflected about the x-axis, but you can't write both. Can't say vertically reflected about x-axis. That's repeating yourself, okay? So if you use reflected about x-axis, you're gonna say, and then reflected about x-axis, you're not gonna say this. Or we say vertically reflected. Okay, that's how it works. So that's very nice. First, a shift up by 2 units, good, and a vertical reflection, good. So that's how we score those 2 marks. Nice and easy. Is there another way? Well, let's think about it. What if the vertical reflection came first? So we could easily say, well, this would be minus into minus 9 over x plus 3 over 2. So this would end up with 9 over x minus 3 over 2. Now what would we have to do? Subtract 2 units. So this would be 9 over x minus 3,5. Okay? So again, we can say if the vertical reflection came first, then we can say this is the graph of g, vertically reflected, and then translated down by 2 units. So there's 2 answers here, not just one. So we can say or, so ibalange color, blue, green, or we can say h is g vertically reflected and then translated down by 2 units. Okay, so whichever came first, the other one follows. As you can see, slightly different answers, but same outcome. So these are some of the things that you must be able to say. So this is still correct. Vertical reflection, yeah, and then a translation down by 2 units, yeah. So that's another way of phrasing that answer, depending on how one looked at it. Fact of the matter is, we need to master our terrain because both of these two literally mean the same thing. There's nothing different about these two in terms of the outcome, but the manner in which we achieve that outcome is just two different ways. Great stuff. So guys, this is a very, very, very important question in grade 12, a parabola and another graph. So this is to be understood in the best way possible. So do more questions on parabolas with other functions together and make sure this is easy, because even in grade 11, please do the same, because in grade 12, this is where a lot of students cry like blood instead of tears. They cry blood here. And this has a tendency to stall students because they get the idea that they can handle these questions, but they actually can't. And now they end up losing time and end up being desperate for questions that are easy. The other thing I would suggest, if you're a grade 10 writing this exam, start here. Because this is the question that usually demands a lot of focus and understanding. Algebra, guys, is easy, man. You just simply know what to do. I don't know why you want to obsess over this kind of thing. Algebra is easy. Start here because this is technical. It's application of algebra and other things. Just start on functions, finish them, because you cannot speed up on these questions as much as you can on algebra. But knowing very well that your algebra is strong, because if your algebra is weak, then you might want to practice your algebra first, then come to functions. But remember, you will lose time. Time is going to be lost. And that's just the enemy in the exam for everybody, including myself. But I was very able to manage time. I always finished my questions. I only could not finish questions I knew I could not answer anyway. But I hardly had those by the time I was doing my June exams, my trials. Yeah, at first, because I kind of took a jump, man, from mainly standard grade to higher grade in my final year in high school. That was a suicidal mission, I promise you, but yeah, it was worth it. Because by the end, by the March exams, I'd already figured out a lot of things, but I was not quite confident because, yeah, every now and then I would choke not knowing what to do until I solidified my 3-step approach. Yeah. And that took me to understand my work very well rather than to hear somebody telling me what to do. I had to combine, though, everything I was told, everything I read, and everything I notice as I go along. Then I put it together. It was a bomb. By June, my teacher was smiling. Yeah, we're going to get this thing. We're going to get this distinction. Trial came. Yeah, it's on site. December came. Of course, we only saw it in January. Anyway, folks, it's not about me, it's about you. Now, here's another function, an exponential. Usually, this is the easiest, I would say. But sometimes it's not as friendly because we typically include inverses on this one. But even for the parabola, though, inverses are included. Anyway, let's go. H of x is equal to 2 to the exponent x, not 2 to the power x, please. So basically, this is in the format f of x is a times b to the exponent x plus q. Just notice, if there's a negative in front of the power, it means it's a coefficient. It's not the base being negative. With functions b, it's either less than 0, greater than, b is either less than 1, greater than 0, or b must be greater than 1. B can never be equal to 1. For this to be a function, b must never be less than 0. This is the law, okay, guys? This is the law. It's the law. And b can take any real value otherwise, except 1 and negative integers. Otherwise, b can be anything as long as it's not 1, as long as it's not 0, as long as it's not less than 0. That's the restriction on b. A can take any real values, both negative and positive integers. Q can also take any real value, negative and positive integers, rational and irrational. But B, yes, it can take real values, but not 1, not 0, not less than 0. Great. Now, there's a few things that we get from A and B. When A is greater than 0, meaning it's a positive number, that combined with B greater than 1. Now, what do we see? First and foremost, this means this graph appears above the horizontal asymptote. Okay? And remember, the horizontal asymptote is always a horizontal line. It's a line y is equal to something. That's the only asymptote we have. There's no vertical asymptote for exponential equations. Although if you think about it though, there is an imaginary one sometimes, but depends on the function, of course. So, secondly, when b is greater than 1, what does it mean? But remember, it depends again on the combination. Now, when a is greater than 0, this graph is going to appear above the horizontal asymptote. But when we combine these two, this becomes an increasing function. Okay? Keyword is the combination of the two. A greater than 0, b greater than 1, this becomes an increasing function that appears above the horizontal asymptote. Now let's go back. The coefficient here is an invisible plus 1. So we know that a here is greater than 0, b is greater than 1. So this combination says we have an increasing function that will appear above the horizontal asymptote, which in this case is, the horizontal asymptote is the vertical shift, which is -4. So this is going to be here. This makes up our horizontal asymptote. Dash it nicely. And our graph has to be stuff like this now. Okay, that is something we expect, of course, these being the x-axis and the y-axis and the origin. So that is the graph we expect to see. So again, guys, these things you don't need a second invitation to notice. Now, a student who understands these things is not going to have to go through this first. We'll just look at this equation and already have this in mind. Of course, I did not work out the x and the y intercept, but it's obvious. If the asymptote is here at -4, it means my y-intercept is going to be very close to that. It's not going to be far, so it's going to be very close. So it should be negative. But my x-intercept is definitely going to be positive. Otherwise, this graph is going to be impossible to draw. So there are certain things you will understand by knowing how to work through many examples. And of course, mastering them each time. And studying them. You just don't solve and get the answer right and move on. Sit back. Notice the trends. Notice the changes with different examples. Sometimes it helps to just take, some exam pad papers. You perhaps solve a question like this on one page. You finish. You study and you understand what you see. Take another example of a similar question, or perhaps a slightly different, whatever, but something on the same topic. Solve it. Then put this side by side and notice, okay, this changed. What do I see? That changed. What do I see? Can I gauge what should be where? looking at what? You understand? That way you become quicker at analyzing questions, and you can easily do this without even thinking about it that hard. It just comes second nature. The moment you see it, your brain will register it because you coded it in your mind. But if you are still startled by these things, ngofileyo thina ke siyakudla sidle fileyo thina xa kuliwa qaqhute manikiniki zindala zombini maths nawe nibadala sawudle fileyo ke ngoku kuzofa wena ke ngoba imaths yona iluqilima isisinyithi njengentsimbi yomelele lento ayigobeki funeka uyitshise ngomlilo at the highest of temperatures for it to bend. Even nalapho uzotsha if you don't wear protective clothing to bend it. So it's not that easy to navigate mathematics, guys. It needs complete understanding of how to do things, complete diligence, due diligence in how to go about business. On top of that, being precise at best. This means most of your abilities here need to reach a near perfect execution, or else you will always be wondering what is the case here. How come I don't seem to do this right? I'm telling you guys because I like you and I want you to know things, because I will not always be around to tell you things like this. I will disappear very soon, I told you. And when I do, you may not see my channel, because the moment I'm not posting, it may go into junk status and you may not see it being shown to you. And if that's the case, that means you might miss the goodies that are in here. Subscribe and share to your friends and tell them to subscribe too if they are still willing to learn something from this channel. And of course, if the channel disappears, because you never know with these YouTubers and stuff, maybe I say things that they don't like, they might just cut it off, you never know. Or I'm doing things they don't want me to show, they might just cut it off. So when you get a chance, learn and reciprocate, emulate, whatever ways of, showcasing what you've seen, do it. So that tomorrow, if this is gone, it's in your mind. It's in your notes. Assume independence as soon as you come across me and my channel. And as soon as you gain your independence, then show others where you got your water. Don't be selfish, because you will need those guys to work alongside you on your big project when you become that exquisite engineer. When you become that good doctor, you will still need a good nurse. And how do you achieve this? By making sure those who come after you also learn from the same well, so that they can be just as polished as you are, so that you don't have mediocre members around you. Just think of the future, not now. Now you may think people are competition, not necessarily. But in the future, I will need the best of them. And they will come in handy if you share things with them. Because you may think they will compete with you. They will never defeat you. That's why I taught my classmates freely. I used to teach my classmates after school. The after school classes, usually for maths and physics, I was the teacher in my school. And in fact, I would go to the nearby schools. So I was at Nkumbulo Comprehensive School in Guatemala. But it's extension 4, I think it's 4. Then I would go from there, just at the corner, not far from Kumbulo. There's a school there, Lifa Ifa. I would go there, teach the guys there. Then sometimes, if time is still enough, I would be going through Tlakula, teach the guys there. And I got exemptions through those guys, because they were barely passing maths and physics, guys. So during these winter schools, when the district teachers changed schools, I went there because my teacher was like, man, I have nothing to teach you. You can pretty much drive yourself forward. So rather go and see how other teachers teach the same subject. So there was one group of teachers who were at Lifa Ifa. So I went there. That was after June exams. So because we finished the syllabus long before June. By May, the syllabus was done. So there was really nothing to go through. So I went there. When I got there, I saw some guys really struggling there. And then I kind of showed them around. And they're like, man, we want to learn. I was like, I'm just next door. So I'll come by, because if I bring you to my school, you'll be slowed by my peers. So I will first deal with my peers, afternoon class, and then I come to you, I teach you. I go to Tlakula, I teach them, then go home. I would arrive late at home. But that helped me to be experienced in teaching people things, explaining things, showcasing. And in fact, it kind of made me aware of some of the faults that I also commit, because then I started to realize, oh well, this is the reason I'm never getting this right. Now I'll never miss it. You know? Yeah. Guys, I'm telling you, you'll never be the best if you just do the bare minimum. Nah, you will look like the best, but you won't be the best. And you will know it inside of you. And that's why we'll run away when someone asks you a question, because you know, yeah, you seem to be a top achiever, but one that is a touchy-feely, like staccato. Kuve staccato. Legato. No, staccato is like touch and go, touch and go. And when somebody asks, I'm coming back, you run away, because you know you can't explain, you crammed everything. And of course, in maths, we can only ask questions in a particular way, you know, and we can ask to a certain extent, of course. So if you've gone through a lot of similar work, there's no way you will fail to make it. But come higher grade questions, they will show us who's boss, right? Right. Because most of those top achievers, they can only manage the common stuff in the majority, because that's what it is on the papers, right? But the high grade questions, they can't answer. They cannot answer. But the true top achievers are the ones that chow those higher grade questions and miss it by a point. Even when they missed it, you'll notice that they miss it on the easy questions because of just a lapse of judgment. They took those questions for granted. They don't check their solutions, because that is usually the weakness of the brilliant students. They tend to take things for granted, and then they fall because of those. Okay, they don't necessarily fall, but then of course, to a top student who gets 100%, 98 is a fall for them. You know, I had a teacher, Memposh. You know, that lady was something else, man. You get a 48 over 50 in a class test, and then she'll be like, I'm giving you 5 lashes. Why did you miss those 2 points? Who did you leave them for? And then you get 20, and then she's like, it's fine, sit over there. She doesn't even care. Sometimes it's bachatis. Avele boy negel besibachatis sibagcwalise flowers move isikolo sonke zonke iclasses ezibona. Hey God, sometimes that thing looked like it's bad, but I can tell you guys, it was not brutal, because it was like, you know, what do you call, tough love. Because I tell you, none of my classmates failed. And I can tell you, most of them, they hardly really were doing well when we were students at first, but I can tell you most of them are living successful lives, depending, of course, on how you define success. Because for me, it's an individual thing. You cannot generalize it. If you try to do so, then you're going to prejudice others, while you will try to overly inflate your self-worth, which is grandiosity and a disease of some kind. Or should we say a disorder of the mind. And it's there in the DSM-5 or 6 or 7 of psychiatry. So if you start to fit a personality disorder of some kind, or some disorder of the mind, then you know you're not very far from being a crazy. So be very careful, eh? Grandiose delusions, typical of bipolar people. Yeah. When they're in the manic phase, they are like everything else. And then, of course, those swings, they swing into some severe depression because you overly charge. You bite more than you can chew, and then that depresses you big time. So, hey, Watch out. Watch out. Anyway, guys, enough of the break. That was a break, by the way. I can't teach you maths only, guys. I need to tell you about life. Sometimes share some of my stories so that you can see where I come from. I didn't just fall off the sky. I became a mechanic, and I suggest you be the mechanic. Don't be the guy who wants the shortcuts and the easy ways of going about life. Spice life. Have shortcuts, have long cuts. You will see that you'll learn more from long cuts than shortcuts. Then you start to develop better shortcuts with better performance, by the way. Anyway, enough is enough. The grandiosity in here is bad. So I am a psychotic. I'm psychotic. Is it psychotic or psychotic? I am psychotic. Yeah, schizophrenia is the one. Or maybe it's just psychosis. NOS, not otherwise specified. Huh? Okay, calculate the x-intercept. So how do we do the x-intercept? So guys, it's easy, this one. I can bet this is going to be positive. How do I know? It's because of the shape of my graph. But if you don't have an idea of what the shape looks like, you might not know if you are right or wrong. But this is going to tell us indeed. Okay, so this means h of x must equal 0. Or perhaps let's just be methodical this time. It cannot be haphazard. We are mathematicians. Order is the order of day. So we know that for x intercept, it is such that h, okay, let's not do it there, h of x can be equaled 0. Yes, we're breaking it to pieces. 2 to the exponent x. Please don't say 2 to the power x. I beg you, my students, but say it for your teacher's sakes, of course. But for your sake, just say inside. After you said 2 to the power x, then say inside, God forbid, that is my mind. Keep 2 to the exponent x, or 2 to the exponent, so 2 to the index x, or the xth power of base 2, right? Say the right thing inside, but on the outside, of course, lip service sometimes is good for the peace, you see. If you start saying too much, sometimes lip service is all that is needed for some people to succeed, right? So we know that 2 to the exponent x, we convert this, it's going to be 2 squared exponential laws. Can you see algebra is back? Therefore, x is 2. Wow. We saw that one is going to positively come. It is almost always the case, most. You will also notice that, trust me, guys, it doesn't work the other way around. Of course, you will understand when you get to logs. If this is already positive, you will never find this one being given as negative, meaning the coefficient of the power, because it would be difficult to solve. Because we can never have any power equaling a negative number. You get it? It does not exist. Because no matter what exponent, if the exponent is the only thing that's variable, you will never have a power that gives you a negative number. So there are certain standards that will tell you that, okay, technically, you know very well that if this is a negative, this one has to be positive. Otherwise, we can't solve for the x-intercepts. They would be undefined. But the question is, if we cannot solve, does that mean we can't have an expression like that? Well, it would mean the x-axis would certainly have to be an asymptote. Because if that's the case, it means we're not going to have the x-intercept. But what else is going to be the case? Well, yeah, it can happen that we would not have it. But of course, the y-intercept will always be there, right? Right. So we'll only have the y-intercept. So again, what are we saying here? We are saying, okay, even if this is negative and this is negative, but we know one thing: if the coefficient of the power the power being 2 to the exponent x, which is the signature of an exponential function entirely. If that is negative and the vertical shift is negative, it means we do not have an x-intercept. So you cannot draw a graph like that with an intercept. But it will only have a y-intercept. You get it? These are the notes, guys. This is not what the book will tell you. You will only see it from experience. What are we doing here? We are calculating the x-intercept of h. Remember, the x-intercept is a point. Please don't just write x is equal to 2. This is just a vertical line, technically speaking. But if we're talking about an x-intercept with a function in mind, let's do the ordered pair. So therefore, the x-intercept is 2 and 0. That's the x-intercept. It's a point on the graph, not just some vertical line. Are we doing a vertical line test here now? Okay, all right, okay. So even if we didn't mark this one, but we need to see it for a full mark, né? 2 marks on offer there. When we substitute 0, yes. When we actually give the ordered pair, I think the rest is applications of algebra, which we are well versed by now. And we are happy because we practiced it from the first few questions. Can you see? The examiners are very nice. You can see that this, if you don't know anything in maths and you're just trying out, start with algebra. Practice your algebra. Of course, if you can keep time. When you get here, you will start to see that I'm applying the same algebra I was doing. Good. But if you are a good student who wants 100%, you'll come here first because your algebra should already be on point. Dance here, struggle, because you cannot move fast on these questions. Algebra, you can move fast because that's the bread and butter. The bread and butter. Calculate the y-intercept. So we can say for y-intercept, it is such that we now are going to say h of 0 is equal to 2 to the exponent 0 minus 4. This implies that h of a 0 is going to be 1. Any base to exponent 0 is 1 minus 4. Therefore, h of 0 is equal to minus 3. Therefore, the y-intercept, remember it's a point on the Cartesian plane, 0 is to minus 3. Can you see? It's never very far from the asymptote. You will never, ever in your life see the y-intercept being so far from the asymptote. It's always very close. And usually they differ by a unit. Just remember that. That's another note. Remember, when you talk notes, guys, you're not talking reproducing what is written in the textbook. That's already a note by somebody else. A textbook is it's just notes by somebody else. So reproducing them is not helping yourself. But when you're writing notes, you're writing things that are not in the textbook, but that you notice as you solve issues in the textbook. Of course, you still need to remember what is on the textbook. You still need to read and read it with meaning and understanding. Good one. We want to see the ordered pair. We want to. Because a y-intercept is a point on the graph, not just some horizontal line. This is literally a horizontal line. So I'm not too sure if you're doing a horizontal line test here or what. But if I say the ordered pair, I know you're answering the question. Unless someone says solve for the y-coordinate of the y-intercept, then I'm happy. So x-coordinate of the x-intercept. Now we know this. We know this. But if we just say find the x-intercept, we want the full point. The point on the Cartesian plane has both x and y coordinates. Please don't take this for granted. It's very important. So here we're just getting 1 mark for the things. This is not fair. This is not fair. This is not fair. 5.3. Now I need to move, guys. I've been talking too much. I'm tired too. I'm hungry as well. It's too late. And I should not be eating at 11. It's because of you guys, because of the love I have for you. Hence, sketch the graph of h on a system of axes. See, no one is trying to say which one. It's nothing but the xy axis, or the Cartesian plane as we call it. But the system here is x and y. You cannot have n and tn, okay? Clearly showing the intercepts with the axis and the asymptote, okay? Very easy. So we already knew the shape of our graph. We just take that and draw it nicely. It doesn't have to be to scale. But as I said, a graph must, in proportion, honestly give us what we expect. We can't have a graph that is totally not representative. X and Y. Please label the axis. Label the origin. Because if I just see lines crossing, I don't know what vertical line that is. I don't know what horizontal line that is. But if I see the origin, even if I forget to write X and Y, just the origin is already suggesting this is the Y and the X axis. Please, students, don't get caught pens down. Of course, I'm going to assume my minus 4 is almost, is it 4? Is it 4? Yeah, it's 4. And it's not 4. It's 4. It's 4. It's 4. Okay, 4. Go 4. Or is it 5? Awuthi kodwa sike sithi uyibhenda kancane. Yeah man. Sibe sesiyamuva ke ngokakuhle nje. Hantle fela. Re itse jwale hore re na le -4 ka mane, ho na le -3 ka mane, ho na le 2. It doesn't mean though that this one has to follow the same scale of the y-axis. You see, don't be fooled by that. I got a learning at no. We can change the scale for the x and the scale for the y. We are allowed to do so. It is possible. So this is the graph of h, guys. We just label it nicely. And how do we get the marks? The shape. It's an increasing function that appears above the vertical asymptote. It is. Then any one of the intercepts and the asymptote. Igqityiwe. That is 5.4 now. Okay, masipalula 5.4. Now the question says write down the point of intersection between these two. Okay. Now we can see that, okay, this is our function that we just drew. But now we have another function right here, but this function is not ready for us to sketch. This one is y is equal to 2 to the exponent minus x minus 4. So what did we do? It means we took this function and did a horizontal reflection, or a reflection about the y-axis, because now the exponent carries a negative. Remember the x values, when we multiply them by negative, we only affect them. So it means we are reflecting this very same graph by how much? We are reflecting it about the y-axis, or we call it a horizontal reflection. Now this becomes a higher grade question, because to notice how to simplify this so that it looks like that, you wouldn't know what you just did. So it means if we're doing the things that we're doing, just take this one and copy. Of course, in the exam, you don't have the luxury for this, right? Then we swing this thing and be like, reflection is going to look stuff like this, right? Because what is x becomes negative. What is positive becomes... But the y value, will notice, will remain the same. Ne? Graph yami kananifanele ibe njani? Xa injeya. The other reflection is obanje. Yeah. It's a horizontal reflection, so fanele ibe nje. Nje kanjalo nje. Now I'm going to dash this one because it's not supposed to be here. So please don't do it in the exam. Rather draw a sketch. But all we know is that If a horizontal reflection is going to say this becomes there, it's going to be -2. Only the x values change. Y values don't change. That's why the y-intercept remains. And guess what? They cross each other at the y-intercept. So this is again the question of saying, write the y-intercept again. You get it? So the point now of intersection is going to be 0 and -3. So this is the common point that will never change over. Never change over. There are no changes there. I gave a word to say really mathematics for paper 1. Of course, I kind of try to take some time so that I can engage you fully and so that you can understand everything I'm doing. Because if you don't understand these things, this would be a grand total of 50 marks. As you can see, we could really chew upon this in an hour, even in 45 minutes. If, of course, we are strong enough, because these are very basic questions, except for 4.6. That's a higher grade question. This one is also somewhat, but students know this. Somewhat a higher grade question. Yeah. That's it. The rest was like pap and flace, pap and flace. So I hope, guys, you enjoyed the video. Give it a thumbs up, subscribe for more. It's still to come, and sometimes it may come when you least expect it, so you don't want to miss out, because the lesser the less I post on a daily basis, the more you will not see my channel. And yet there will be videos that I will post sometimes at irregular intervals. But what if you need the piece of information at those times that I'm posting it in? So you might as well just subscribe. It doesn't cost you a penny, guys, to subscribe. I don't know why you don't want to subscribe. Even if you don't care about my channel, just subscribe. Do you know what you're doing when you do that? You're not helping me. You're helping your peers. You are helping the country for free. You get it? Because those who will benefit from this are going to make your life easy, because some of them are going to become inventors of things that you may benefit from. Some of you are going to become maybe your doctors. They will treat you when you have cancer one day. You never know the future, guys. So always think of the future in mind, that you might be in need of the people you are starving information today. Sometimes it may not be relevant to you, but just know when you subscribe, when you like, you actually make the channel more suggested to other students who may bump into it. And if that's the case, they can learn something. When they learn something, they become better. When they become better, you will need an accountant tomorrow. It could be one of those people you helped by just subscribing, even if you didn't care to see what I post again. Maybe you feel like, this guy is just babbling. But those babbles, if you just subscribe, I promise you, you will be helping someone. Just a like, even if it's a careless like, even if you didn't watch the video, just see this video, just click like, go. Because one thing for sure is that when you open it, just let it maybe play for like a few seconds. It's going to register a view. Views sometimes make the channel suggested to many others, depending on how quick they come. So just a small nyana view. That like, just mindless, even if you don't care, just like it, just religiously, just make it a habit. I'm just gonna like it. Any educational content, I'm just gonna like it. Then just hit that subscribe button, and then perhaps turn off the notification bell, so that if I post something, it doesn't meddle with your life. But just those subscriptions are going to make the channel be recommended more. And the more it's recommended, the more kids it reaches. And the more kids it reaches, the better it performs. Remember, guys, even the money that I make from it, if I will eventually monetize, I'm struggling to do so because YouTube is saying they're sending me a pin, but it never arrives in my address. I don't understand where they're sending it. So as a result, I cannot. But when I finally can, because it will be possible someday, do you know that if this thing is making good money, that good money can help you, the very students, because I can get people who can teach other subjects better. At the end of the day, you end up finding a home where you can find everything that actually enhances you at your convenience. 2, who knows what it can bring forth? You never know. Some school, or it can be something that can donate textbooks and study guides to students, the best that you can find. Calculators, because not many of you can afford these calculators. We give you a 4ZZ for free because of, the contributions these guys are going to make. Look, guys, I don't really need your money for survival. I'm surviving just fine with the little bit that I make from my job. I would not rob you of a cent that your parents work hard for. I know its value. I've been there. But I wouldn't fail to take, some fruits of my hard work, because this is hard work. To give you these lessons, it's hard work. Trust me. For me to sit here for hours talking to myself and the screen and pretending that you are here listening, it's no joke. I sound crazy to those who know I, at the moment, am alone in this room. They'll be like, who is this guy talking to? I'm actually doing these videos for you. So I look and sound crazy to those who are nearby. But do you see those kind of things? And I'm sacrificing my work. I should be studying my books only, doing my research only, preparing my presentations for the departments, preparing for congresses. There's an upcoming congress in August. I should be presenting there. But I'm not doing those things because I'm trying to leave something for you folks. So it wouldn't hurt to get me a little bit of that money there, because if it can pay my DSTV account, put some petrol in my car, and relieve me from house expenses, then I can be able to take my nieces to higher education, all of them at once. Now I can only take one at a go, you see. So those kind of things, folks, they make the world a lot better. Trust me, it's not about being filthy rich and living a soft life, but a decent life that has meaning and impact. So please, those who sell their work, support by buying if you can afford. Okay, please do. Those guys, it's hard labor to do these things, folks. Do not take this for granted. Some 20 years back, there wasn't any of this. You wouldn't find any of this on the internet. Even the internet was not anything available at the time. Even the phones. Yabona ifone engcono ngelaa xesha ndandisi-student matriculant was Nokia 3310. That was the best you could find. Butilili lo phone le. Okay, so that was what was the best at the time. Although ifone isiqala ufika ke sizazi nathi ngamagama ngabo 98, yabona, but besingekabikho that advanced. So quickly after that, ntensesemedunso kabe kufika iBlackberry naye yayibutilile nyana, butililarha ngayibiza kanjalo, sabutilili sabo something, and then quickly kwafika iBlackberry Torch, yaqala ke ngoku ingxaki. Kwaba kuhle ke ngoku sabona boMotorola bafika ne-flipping phones. You could take pictures and stuff. By the time gqiba, kwasekwenziwempu kakhulu. Smartphone, touch screen and stuff, So guys, all these developments only came because people were supported, and they took those supports seriously, and they also gave back. So don't shy away in subscribing, because it's not only, in fact, it's not even you who pay. It's actually YouTube that pays. You see, YouTube is paying. Where now all you have to do, just give a view, give a like, subscribe, even if you don't care. You will be surprised how so much good you'll be doing to others who will actually benefit you. As I say, you will have children in the future. They will need good teachers. Those good teachers will be the results of what we are doing right now, that you don't want to reward with just a like, which is free of charge, with just a subscription, which is free, and you can even manage how that subscription works for you. All that matters for this channel is just for that subscription to be registered in. And in fact, to leave it there and not even unsubscribe, because if the notification bell is off, you will not be bothered when I post, you see. It's just that you will have access to those videos as soon as you want them, or at your request, or at your will. All right? Okay, all right. So guys, let's do the right thing. Subscribe. Not for me, but for all of us. Of course, I will have a little benefit if I get paid, but I promise you folks, that benefit will also be to improve you more than it will be to improve me. I can improve myself. I'm on the process of doing so, and I'll definitely improve with or without you. But the sad part is that if I do it without you, then I'm not going to look in your direction. But if I do it with you, I'll certainly ensure that you also improve along with me. I'm going to cause a vertical shift or a horizontal shift to the right. You get it? So remember that. Or I can somersault you far forward than I can be. You know, I could remain where I am, but somersault you ahead, like reflecting you and translating you at the same time. I can do it if we do it together. But if I do it alone, then I'm going to be limited in what I can do for you. The moment my little niñas come into this world, then I'll have to focus on them and forget all of you. But if you are here and you are there, I'll make sure my little niñas know about you. And they are just there with you. And who knows, you might just help me with my niñas and teach them well. Because I'll be learning from the best, which is you. You are the best. You will be the best. You just have to will, you just have to work, and you just have to win. All right. See you guys when I see you. Of course, I'm going to do a paper too for you guys as well, just so that by the time you write your exams, at least you are a little bit familiar. Of course, don't worry about the province from which I took the paper. Don't focus on that. It's not about a particular province. It's about the content, guys. And whatever I can get my hands to, and when I look at it, I see that it has some very good points for me to make, I will use it, okay? So don't undermine a province. Don't undermine the quality of paper. Sometimes it may be simple questions, not higher grade questions. It's not about higher grade questions per se. It's about the content. It's about the knowledge. If I choose a paper, it means I have a point to make. Just remember that and try to find that. Even if I don't say it out loud, there is definitely a point I'm making. Follow that point, okay? All right, okay, guys. Before I say more than I'm supposed to, let's wave goodbyes until next time. Tomorrow, I should be dropping a paper too. Then once those are in and you've checked and you've practiced, then we can start dancing around different types of questions and flavors and whatever, just so we can solidify what we've done. Otherwise, until then, goodbye.